All right, guys, in this short clip, I would like to show you guys how to do the questions on quiz number 10. And I think most of you, many of you did a very good job, but I think some of you may not have watched the lessons, or I'm just guessing. And these questions are very typical of questions in calculus, which you need to, of course, we're not doing the calculus class, we're doing the algebraic part that's needed for your calculus class. So we're doing the algebra part. This is a quiz number 10. So I'm going to show you a solution to this quiz. Okay, so it's called solution to quiz number 10. How do we rationalize the numerator? The numerator, okay? So, well, they're not in fraction form, but in fact, you view them as, you can view the first one as, this one can be viewed as something like this. Okay, so let me make the fonts larger. So then we have a numerator. So we need to get rid of the radicals in the numerator. The way we do it is we multiply by 1. Okay, and of course we're going to make our 1 in a special form. And that special form is going to be square root of x squared plus x, which is the conjugate of the numerator. Okay, so that's the numerator. And since we're multiplying by 1, so the denominator must be the same. So we pay tribute to principle number 1. Okay, anything times 1 stay the same. And the next step, you would use the conjugate property. Okay, so you take a numerator, multiply numerator, right? So that is, of course, most of you guys know that A times A minus B multiply A plus B, the result of FOIL is equals to A squared minus B squared. And what is our A here? Our A is square root of x squared plus x. So that's our A. That's our A. Okay. And what is our B? Of course, B is x. Okay. Minus x plus x. So on the other side is going to be A squared minus B squared. Okay. So our next step, we're going to get this piece. Replacing, which is the result of multiplying these two, and we're getting that, right? And so this is what we have left. Okay, now, and the rest is a simplification. The rest is simplification. So what is this root of something squared? Okay, in other words, what is root of, say, let's see, let me just give you a little more space. Okay, so what is this piece? Heart. Okay, square root of heart, parentheses squared. What is this equal to? Okay, we have addressed that issue before in one of those lessons. Here, I want to bring this up again. It's going to be heart. Okay, then you might also think of these other one, right? So what if I have heart squared? What does that equal to? Are these two the same? Is this expression and the other expression the same? The answer is no, they're not the same. Big difference, okay? So I'm going to explain this after we finish this question, because the latter equals to the absolute value of the heart. Okay, so the heart is as a placeholder, and you can replace it by X, you can replace it by Y, you can replace it by whatever symbol of your choice. Okay, so this piece we have here is the first case. Okay, the root, after taking root, we square it. Okay, so then here we got, what we get is that we're gonna have x squared plus 1, x squared plus x, on the top minus x squared, and the denominator, of course, stay the same. We're not going to do anything about it. You don't need to do anything about it. So we're almost done. Okay, so the next part is, of course, x squared minus x squared is going to be, it's going to make 0, right? So we only have x left. Anything else can we do? Not much, okay? By the time you're in calculus class, you may need to do some more, depending on the situation, But for the purpose of this question, you're done. For the purpose of this question, you're finished. It's rationalized. The numerator is rationalized. There's no more radicals in the numerator. Now, let's explain the difference between these two. Okay, are they the same? Okay, what are they? One situation is that, and the other situation is this piece. Okay, you can typically say, hey, what if I just make it x? What's the difference? The answer is they are very different. What's the difference? To understand the difference, we have to see the order of operation. Okay, the first one, right, is an operation. It's a set of rule, right? So x is the input. After this x is served as the input, we're going to do root x first. So root x, take square root. After we get the square root, and then we square the square root. Okay, so we square the square root. So that's the order of operation. Then we're done. The latter expression is different. The latter expression is that once the input is given, right, and the input will be multiplied by itself, which is x squared. So we get x squared. After we get x squared, and then we take the square root of x squared. So that's the order of operation. And we understand the rule or the function determines domain and range. Because of this order of operation, domain, the first operation, which requires that the domain has to be, x has to be greater than or equal to 0. The latter one, however, right, we take a root after the input is being squared. So the input can be negative, because negative times negative will make non-negative, right? I'm sorry, negative times negative will be positive. 0 times 0 will be 0. So the input for this one can be any real number. So the domain, the latter one is any real number, from negative infinity to positive infinity. So that difference makes a big difference. When we see this expression, when we see the first one, by default, we know that operate on this rule, it has to be, x has to be greater than or equal to 0, because we can only operate in the domain. So the answer is going to be X. And the latter one, right, as we talked about before, right, you go back to the first week as we address these issues, because X can be any real number, right? So the answer is going to be the absolute value of X. So that's the difference. Okay, so that order makes big difference. Now, how about for root 3? Okay, how about for root 3? For example, if I have cubic root, right? Cubic root, and then to the power 3 versus cubic root, x raised to the power 3. Are these two the same? Are these two the same? Think about it. Okay. So you can also go over by the domain and range issues, and the domain is all real numbers. So these, in the odd number root case, these case, that's the same. They are the same. Okay. So you have to be very careful when domain, because domain is determined by rule. The second question on the quiz, it's very similar technically. It's very similar technically. But I want you guys to pay attention to how you show your work. You need to show your work nicely and neatly. And of course, always correctness is about all things, right? Over 1. Don't have to write it this way. Okay, you don't have to write it this way. But if in case that if this helps you, right? This is a conjugate is a plus 3x. And the conjugate is plus 3x. So we go by the same, almost the same thing. Okay, numerator times numerator equals denominator. So we have this piece, right? Squared minus 3x in parentheses squared. Some of us miss that. Okay, some of us miss that 3 needs to be squared too. Okay, so the next step, of course, you will get to the arguments are pretty much the same. Okay, so here you're gonna have, and over here is gonna be 9x squared. Okay, 9x squared. And of course, in the end, you will get x over, oops, my bad. Okay, x over the previous denominator. All done. That's all done. Okay. So that's quiz number 10. That's quiz number 10. I want you guys to work nicely. Okay. Common mistakes I saw. I saw some mistakes. Mistake I've seen. Okay. Some people might have written in this way. Okay. This way. You can write it this way. You need parentheses. If you don't have the parentheses, it's a mistake. That's missing parentheses. Okay, the parentheses are necessary. Parentheses are necessary. Okay, so the correction would be that you need to insert parentheses. Okay, I think that's all for this time, and thank you for watching.